Hello, welcome to Brilliant Academy. In today's class, you're going to learn about inverse function. Now, this is how actually the inverse function works. So, let's say we are given a function f of x. The inverse of this function is given the notation f of x into the power of minus 1. So, the inverse of this function will be given as this. So, let's say we are given a function f of x is equal to 2x minus, let's say, 3. Now, how do we get the inverse of this function? Now, let me give a quick explanation to this. Now, if I'm going forward, the inverse of it is that I'll be going backward. So look at this equation, this expression. If we have this as 2 is multiplying this, the inverse of it will be that it is being divided by 2. If we have this part of it that it is minus 3, that is deducting 3, the inverse of it will be that we are adding 3. So let's see how mathematically we can actually do this to get the inverse of it. Now, the procedure to get this is that you take any alphabet, let's say y. So we say that f of x is equal to y equal to 2x minus 3. Now, for us to get the inverse of this, we swap x for y and y for x. I'm going to explain that shortly. So, where we have y, we are going to put in x. Where we have x, we are going to put in y. So, it will be such that 2, instead of multiplied by x, we multiply by y minus 3. Now, this equation that we've set, if you make y subject of the formula, that becomes the inverse of this, which is written as this. So let's see about that. So making y in this expression subject of the formula, we can move minus 3 to this part, so that we have only 2y. So we have that x. If we take this to this part of the equation, the sign changes to plus. So we have x plus 3 equal to 2y. Now this can also be written in the form 2y equal to x plus 3. 2y equals to x plus 3. Now, to make y the subject formula or subject of the expression, we divide 2 by 2. So we have that 2y all over 2 is equal to x plus 3 all over 2. Now, looking at this part of the expression, we have 2 at the top, at the numerator, and also 2 at the denominator, meaning this can cancel out. So we have just y here equal to x plus 3 all over 2. Now we've successfully made y subject of the formula. Now what we have now is not the inverse of this function. So we take this to represent y. So we say that f of x to the power of minus 1 is equal to x plus 3 all over 2. So this is now the inverse of this. Now remember my explanation from the beginning. Looking at this, we are multiplying by 2. The inverse of it is that we are dividing by 2. Looking at this, we are subtracting 3 from the expression. So this we are adding 3. So mathematically, this two more problems to enhance your comprehension. Okay, so let's see how to get the inverse of this. We've actually done a more simpler one. Let's see how, using the same procedure, let's see how we can get the inverse of this. So, using the same procedure, we have that y, this function should be represented with y equal to 3x plus 2 all over 2x plus 4. Now, we replace x with y and then y for x. So we have that x instead of y, we're putting x equal to, here we have 3x, we're putting 3y plus 2 all over 2x plus 4. Sorry, 2y instead. So we have this. Now, making y subject of the formula in this expression gives us the inverse of this function. So let's make y subject of the formula in this expression. So we have that this we can do some cross multiplication. We multiply this by this. So we have that x multiplied by this. So this goes to this way. We have 2y plus 4 equal to this. So we have 3y plus 2. So this is equal to this. Let's expand this bracket. So we have that x multiplied by 2y. We have 2xy. X multiplied by 4. We have plus 4x equal to 3y plus 2. So we have 3y plus 2. Now let's take the like from this. So we have that this place we have y and we also have y here. So we can write that 2xy. We take this to this part of the equation, the sign changes to negative. So we have minus 3y equal to, we have 2 here, and this is having x, so we can move it to the other part of the expression. So going to this part of the expression, it will be having a minus sign. So we have that 2, this goes this way, we have minus 4x. So we can factorize out y here because we want to make y subject of the expression. So taking out y from this, let's say we take out y, bracket open. What will you multiply by y to give you this? That's 2x. So 2x times y will give you this. We bring down the sign there. What will you multiply to y to give you 3y? That's simply 3. So we multiply y multiplied by 3 will give you 3y. Now this equals to 2 minus 4x. So from here we can make y subject of the formula, dividing 2 by the coefficient of y. So we have that we can divide this by this the coefficient of y. So we have that 2x minus 3 in brackets. We divide the other part of the equation with same thing. 2x minus 3. So this can cancel out this, but they are the same thing. So we have that y is left. So we have y equal to 2 minus 4x equal to all over, 2x minus 3. Basically, no need to put the bracket sign. So this is now the inverse of this. We can put in the notation f of x inverse is equal to 2 minus 4x all over 2x minus 3. So this is the inverse. Sorry. The inverse of the function given here. Now let's see this the function, and let's see in the more complex form. So let's say we are given two functions, f of x equals to 5x plus 1, and we are given another function, g of x equals to 3x plus, let's say, 2. So most times in your test and exam, you'll be given different functions, let's say 2, and you'll be asked to find f of g. So basically, you have something like this. Let's say 1. You'll be asked to look for f of g, and secondly to look for g of f. So this is basically how most times, this is just an intro or an insight to the topic itself. So let's see how we can get f of g and g of f. So for the first one, f of g basically means that instead of putting in x here, we are going to take the value of g of x to put in as x here. So it's more like this thing, this function is more like we have it like this. So instead of having x here, we put the function that represents g of x into the function of f. So what I mean is that we have here we have f of x as 5x plus 2. F of g will now be 5. Instead of writing x, we put in the expression for g of x. So you get, instead of putting in x here, since we are looking for f of g, we are putting in g. So let me just make this to simplify it. We are taking f of g. So inside the bracket, what will be put here will be the expression of g. So what we have here basically is 3x plus 2. So instead of writing x, we put down 3x plus 2. So 5 multiplied by this plus 1 plus 1. Now, if you simplify this, that is now f of g. So let's quickly simplify it. So we have that f of g is equal to 5 multiplied by 3x. We have 15x. 5 multiplied by 2, we have plus 10. And the last one here. So adding up, we have 10 here and 1 that are like 10. So you can simply add them up. So we have that f of g is equal to 15x plus 11. So this is for f of g. Let's see how we can get g of f. So we have that g of x is equal to 3x plus 2. So we have this is equal to get g of f, given as g of f, whatever we have here as x should be replaced with the function of f. So the same thing we did here. For here we are looking for f of g. So the x value is being replaced by g. But in this case we are looking for g of f. So whatever we have as x should be the function of f of x. So what I mean is that instead of writing 3x, we take the value of f of x to impute here. So we have that this is 5x plus 1. So 3, instead of x, we have 5 plus 1, bracket close, plus 2. So simplifying this, we have that g of f is equal to 3 multiplied by 5x. We have 15x. 3 multiplied by 1, we have plus 3 and 2 basically. And simplifying this further, we have that g of f is equal to 15x. We actually add up this because they are like terms, plus 5, 3 plus 2. So this is now g of f. So let me quickly just give a wrap up to what the concept behind this. So actually, for f of g, the x should be replaced with g of x. For g of f, the x should be replaced with f of x. So that's basically the concept behind this. I also have videos on how to find the inverse of f of g of x, and some other complex problems. So if you want to go through those videos, check on the description. You will see a link to that video. See you in my next